Okay, this is Math 2, Unit 13, Section 2. The last piece, we're talking about volume of spheres. We also talk about the volume of a hemisphere, which is just half of the volume of the sphere, so you can just divide by 2 at the end. We need to know a little bit of information, so we're going to talk about these different pieces. First of all, this point in the middle is called the center. This piece right here is called the radius because it starts at the center of the circle and ends on the outside. Up here we have a segment that goes all the way through the sphere, just like a segment that goes all the way through the circle. That is our diameter. And then this circle around would be our circumference. But if it's straight in the middle, that's called the great circle. It slices it into 2 hemispheres. So it has to be in the very middle to be the great circle. Okay, find the volume of each sphere below. So my volume formula for a sphere is listed on the left. So I'm going to do 4/3 pi times my radius cubed. My radius here is 7. So we're going to take 7 cubed and then leave pi in our answer at the end. So that's 7 times 7 times 7. 7 times 7 times 7. You can also raise 7 to the 3rd power using this up arrow, we call it caret. That gives me 343. Then I need to multiply it by this fraction. So you can either put this in as a fraction, or we can just put this over 1, and we're going to multiply by our numerator, times 4, and then divide by your denominator. So we should have 7 times 7 times 7. You're going to multiply by 4 and then divide by the denominator, which is 3. And this actually gives us a fraction, so you want to leave your answer in terms of a fraction. So let's just multiply our numerator. 7 times 7 times 7 times 4. 343 times 4 is 1,372, and we're multiplying by pi as well. And then our denominator is 3 times 1 is 3. So if you don't get a whole number, leave it as a reduced fraction, and leave your answer in terms of pi. And don't forget that will be inches cubed because we're talking about volume. Number 2. Be solved exactly the same way, except for you're given a diameter. So if the diameter equals 34, then your radius is half of that. So half of 34 is 17, and you'll use 17 in place of r. On number 5, you can use the volume of a hemisphere, but most of the time we'll use the volume of the sphere and divide by 2 at the end. So you don't have to use this. You can use the volume of a sphere, which is 4/3 pi r cubed, and then we'll just divide by 2 at the end, or take half of that at the end. So 4/3, my radius is 5, so 5 cubed. 5 cubed, 5 times 5 times 5 is 125. So this is 4/3 times 125 times pi. Well, I know that 4 is not divisible by 3 and 125 is not divisible by 3. So I am going to get an improper fraction. So let's just multiply our numerators straight across. 4 times 125 is 500 times pi. And then 3 times 1 for my denominator is 3. So my answer will be 500 pi divided by 3, or over 3, kilometers cubed. Wait, that's not my answer. I made a mistake. This is the answer of a sphere. So make sure you back up because that's the answer of a sphere. Half of that, you're going to divide that answer by 2, which would be 250 over 3. 250 pi kilometers cubed. And that is the volume of your hemisphere. Those are common mistakes we make, so make sure you're watching out. You could also multiply 500 pi over 3 times 1/2 to cut your volume in half, and you would get 500 pi over 6, but you would have to reduce that to 250 over 3. So what I ended up doing is just dividing my numerator by 2 in order to reduce that. So if you divide each of these by 2, it reduces to 250 over 3 pi kilometers cubed. So go ahead and fill in those other 2 problems that we did not do after we finish number 7, because on the back side we're going to do the application together. We have a hemisphere and a cylinder by the looks of it, so we're going to read the question. The Henleys have a silo on their farm to store grain. Assuming the entire space is used, what is the maximum amount of grain the silo can hold? So I want to find the volume of this shape. From the bottom to the very top is 45 feet. My diameter here is 22 feet. If I want to know the distance between the center and the height of this hemisphere, then that's going to be my radius, which is half of my diameter. So half of 22 feet would be 11 feet. That also can help me find the height of my cylinder. The height of my cylinder is not 45. The height of the entire silo is 45. So I take my radius and I subtract that from 45, and you get 34 feet as the height of your cylinder. We're going to solve for the volume of the hemisphere and the volume of the cylinder, and then add them together. So the volume of the cylinder is the area of the base, which is pi r squared, times the height. Well, my radius is 11, and my height of my cylinder is 34 feet. So you're going to do 11 times 34. And we get 374 pi. We'll worry about calculating pi into our answer at the very end. So we're going to find the volume of a sphere. So there's my little sphere, which is 4/3 pi r cubed, which is from the other side. That gives me 4/3. My radius is 11, so we're going to do 11 cubed. Don't worry about pi at the end. So 11 to the 3rd power. Looks like this. 11 to the 3rd power. And then we're going to multiply that by 4. And that's going to still be over 3. So that gives me 5,324 pi over 3. I need to divide that by 2 in order to get a hemisphere. So that divided by 2, or half of that, my numerator divided by 2, oops, sorry, 5,324 divided by 2 is 2,662. So the volume of my hemisphere is 2,662 pi over 3. I need to add those two together to get my final answer. So And remember, our answer has to be a decimal since this is an application problem. We're going to deal with the very real numbers. But we're going to add 374 pi plus 2,662 pi over 3. Alright, so I'm going to just calculate that first number. I'm going to divide that by 3. And then multiply by pi. Which gives me 2,787.63. And then 374 times pi is 1,174.96. And I'm going to add those together. So adding those together, I get 3,962.59 feet cubed, which is the maximum amount of grain the silo can hold.